Everyone, my name's Louis. I'm a software engineer at DataCamp, and I've been working on building out our design system for about the last year and a half now. And so I'm going to talk today about some of the lessons that I've learned over that time and some of the practicalities and some of the things we've run into whilst building that out. So before we dive too deep into it, I just want to say this is going to be an overview of these discoveries. It's not going to be a deep dive on any specific part of it. I'm hoping to cover it in a broad sense. I'm going to list all the tools that I mentioned at the end. So if you do want more detailed information on anything in particular, there's loads of great resources if you check those tools out, their own documentation or blog posts, etc. And then also, if you ask questions using the chat feature, I should have a bit of time at the end to go back through and answer questions. So what are we going to talk about? These are the 8 things that I've come up with for the things we've learned. First one, we need a design system. Obviously, that should be self-explanatory given that there's 7 other lessons. Second lesson is going to be about some of the content that we already had at DataCamp and how we were able to leverage that to make building the design system easier. Third lesson is going to be a little bit about the architecture of it, and then continuing into the fourth about how you can actually make the local development of these sorts of systems easier. 5 and 6 are going to be touching on atomic design, which is a really interesting design principle, and it applies well to this sort of thing. And then 7 and 8 were a bit more to do with process and how we choose what to work on and how we design our components. So let's dive right in. The first thing, we needed a design system. So to be able to talk about that, we need to ask, what is a design system to start with? So a design system is a collection of reusable components guided by clear standards that can be assembled together to build any number of applications. That's quite a broad definition. This is one of the many quotes that I could find. No one really totally agrees on what a design system is. It's a pretty broad concept, and different companies or organizations could have varying levels of detail into what they would consider a design system. But the principle of it is this, that it basically is the building blocks for whatever you're creating. So this is the New York City Transit Authority Graphic Standards Manual. This was written in 1967, and it's one of the first complete design systems. So we see that it's not a new concept, although within our world in tech, it's a bit of a buzzword, hot topic for the last few years. Design systems have been around for a long time and apply to things far broader than just web design. So here's an example of a page from that design system. And so you'll see here it contains guidelines for the layout, typography, the colors used. It might be a bit small to read, but the text at the top contains a lot of contextual info about this. So not only is it just a description of the colors or what font to use, it also contains the contextual information about why you would pick a certain color at a certain time or a certain size font. What is the meaning behind each design decision being made? And so here you see this very iconic sign that is immediately obvious, even to those of us that have never been to New York, as a New York subway sign is very obvious. And that's because of this clear identity that is laid out through the design guidelines that we all implicitly become familiar with over time. So within the tech space, there's loads of design systems. Everyone's getting into it. There's a lot of implementations. They all have different scopes. Some are made to be very themable and usable by lots of organizations, some of which are incredibly specific for the company that's creating it and using it. Some of them go all the way towards fully unique components that are interactive and contain a lot of logic. Some are just style sheets. Some are simply documentation. So we can see it's very broad. But the principle of what they all try and solve is the same thing, which is this consistent user experience. consistent user interface and consistent branding across all the products. So why would we need one? So I work at DataCamp. We produce data science education materials, and it's an interactive online learning platform. So if we look at our products, we have multiple. We have different applications, some to find content, different types of content that can be taken. We have our marketing pages. We have all sorts. This is probably a familiar story to a lot of you. If you work in a company above a certain size, you're going to have more than one service and more than one application, even on the front end. Another compounding factor for us is that if we want to throw another buzzword in, we're somewhat inspired by the Spotify squad model. So these applications are also being built somewhat in isolation by different teams. And so we see that this can result in inconsistencies in the visuals. We can see sometimes these sites look different, but also inconsistencies in the user experience, in certain patterns of user behavior are different between different applications, and it doesn't feel like a cohesive unit. So that's where we were, and we decided we needed a design system. Now, obviously, every design system is a single word noun that's seemingly unrelated to what it's doing or the company involved. So ours is called Waffles. We're a Belgian company, and it's a nice word, so that's what we use. So we've established that we need a design system. Most likely, most companies will need some level of this. It's going to depend on the size of the company and the number of products as to how formal it needs to be, but it's going to need something. So if we assume we're going to build one, where do we start? How can we get going on that? So that's why we say use what already exists. So I wrote this statement. I'm not a business expert, but I don't think it would be wise if you're starting a new company to start with building a design system and 2 years down the line, build your first product. So most likely, if you're at the point where you're deciding you need to build a design system out and formalize that design language, you probably already have multiple products. And so instead of starting from scratch, it can be easier to go and look into your existing products and pull out what you need. And maybe you already have some of the materials that are halfway towards the design system that you envision. So maybe you already have some sort of style guide. In our case, we had some shared SCSS files that contained a lot of this information that is necessary for a design system. It's pretty good, actually. It's a long way towards what we were talking about before. And you see here a screenshot of some documentation about our colors. There's other sections about typography, font sizes, that sort of thing, as we spoke about before, spacings. Where this maybe falls short compared to the vision of a fully featured design system is firstly in that because it's purely SCSS files, it lacks the user experience element. So the behavior patterns, because we can't include any interactivity here, it doesn't really cover that. Also, the documentation is very much a technical documentation. So it contains all the information for an engineer to be able to use this stuff, but as a designer or as someone else in the organization, it doesn't necessarily contain all of the context or the decision making as to why you would pick, for example, here, you see our different shades of our primary blue color. In what circumstances would you pick the different shades? And so there's nothing that determines that or why you would use these different steps. However, it's a really great place to start from because we know that these are the colors that we're going to use. It's not worth reinventing the wheel. We're going to take the existing style guide and we're going to help to contextualize it and maybe build on top of that. Perhaps also there's already some shared components. So within applications, they might already have components. And then in our case, one of our teams already started some work on extracting some components from their applications. So they have, if it's a team that has to support multiple applications, it can be in their best interest to have already started doing this. So you see here, there's some components that they had already extracted, so icons, there's some tags here. You see the list on the left-hand side of what those components were. And so this is great as well, because this is somewhere we can pull from. Again, it's not complete because this has just been designed for the one team. It lacks the context. It doesn't have the documentation behind it. It probably doesn't have the same level of testing or quality as something that you're intending to distribute to a large group of people. But it's a great starting point, and it allows us to be able to pull in components. And having already learned some of the lessons maybe from the API design of some of these components. For example, there's a button in here, and we could learn from the usage of that button, maybe where it falls short a little, and continue to go from there. So the important thing was not to start from scratch, but to start using things we already had, so that we could continue the visual identity that already existed within DataCamp. Even if it wasn't completely consistent, there was already some there. So then you've decided you want to build this. You've decided where you can get some inspiration from and where you can already pull in some code even in some cases. But you need to actually build something. So we're engineers here. There's a lot of theoretical knowledge about design systems. There's a lot of materials dating back to the 60s with these sort of massive print manuals of design systems. But we're engineers, and we want a way to not have to read all of that every time we want to do anything. So we have some problems to solve. We want to distribute components. So our consumers should be able to install a package and it just work. We don't want to have to mess with configs. We have a lot of different engineering teams who all work in different ways. We don't want to be introducing overhead on them just because they want to use our packages. There needs to be a way to override styles and customize the components. So although we've said before that we want this consistent identity and what you need to unify on this vision, there's still an element of we will never be able to cover every use case. There might be cases where someone needs to change a margin or something to make it fit or do some custom work. So we need a way that we're being prescriptive about how things should be used and how they should look, but with that backdoor so that if an engineer needs to change something, they still have a way in to do that. It needs to be easy for our consumers to upgrade to new versions. So this is the case with all libraries, but it's probably even more exaggerated with something as visual as what we're building. When you ship a library and you say, add some bug fixes, make some changes, ship a new version, obviously we all want all of our consumers to upgrade to the latest version immediately. But what's the risk of them not doing that? Maybe they don't get the fix, maybe they don't get the latest functionality. In our case, when it's visual, that application could start to lag behind visually from the other applications if we start making changes to things. And so for us, it's very important that all of our consumers can upgrade very easily. We want to make that least resistance possible to be able to upgrade versions. And then to go alongside that, we need all of our consumers to be able to trust us. Need to trust the functionality itself so that they're willing to use it, and also trust the versioning so that they can rattle through versions when we release them without having to feel scared and need to go do a lot of independent testing on those things. So these 4 points are 4 things that I came up with as being key problems to solve within the architecture of building this library. And to some degree, these are the case for all libraries. If you're distributing a library, the problems are a little different to if you're building an application. In our case, some of these are slightly more exaggerated due to the fact that what we're building is so visual. So what were the architectural decisions or the technical decisions that we took to solve some of these? So to start with, we use React, since that's what most of our applications are using. None of the following is specific to React. It could apply to Vue or any other component-based system. However, for what we're building, components are important compared to, say, templates in another paradigm. Here, when we're doing component-based front-end work, it allows us to ship logic related to them. So as we get further into building out this design system, we're trying to encourage these UX patterns by having the visuals live with the logic that goes with them. component-based systems are key for that. We're using React, but Vue or Svelte or any of the others would also be the case. We're using TypeScript as well because some of our teams use TypeScript, and it's a nice value add for them if our library supports TypeScript, although that's far from essential for what we're doing. How do we style it? CSS and JS. I know that might be a bit controversial for some people. There's pros and cons to using CSS in JS. We use Emotion.js as our library for this. Could use styled components or any other of these systems, but we use Emotion.js because of the out-the-box config. So again, we want our system to be plug and play. We want people to be able to import our components and it just work. And Emotion was the one that required the least config and knowledge about it for external teams to use it. So for example, if a team's using server-side rendering, they don't need to configure anything differently to use our components if they're using Emotion. So that's why we chose that. Let's talk about why CSS and JS in general is useful for what we do. It allows us to encapsulate styling into components. Now, I don't know if this is particularly easy to read, but this is a screenshot of one of our components. And you can see the syntax here is there's an additional CSS prop. So within our render, we are rendering a text element, and we're setting a CSS prop that sets a few things, the color, a radius, background color, and some other styling. So the nice thing about this is it allows us to include logic like controlling the CSS via a prop. So in this case, it's a tag that you can set a background color on. By setting that color, if we were using a purely CSS-based system, we could here set a class on this element, which is then controlled. However, then we rely on our consumers having the relevant style sheet available within their application. Whereas we want this to be plug and play. So if we look at the transpiled version of this, which is obviously harder to read, but we can see here that all of that CSS information that we had in our code is still within the transpiled JavaScript that's going to be run within the application. This allows us to ship, for example, a tag here where someone can import this component and it will display on the page with exactly the styling that we ship with it without them needing to, one, include the right CSS file that we would also have to distribute, or two, include a build pipeline to work with the SCSS files that we were shipping before. So this is great. It allows that plug and play functionality that we were after. To go along with that and to address the point about customizability, we do always include a class name prop. And not only do we include a class name prop, we pass it straight through to the component that's being rendered. So if we go back to the example before here, we see that there's the CSS prop on the text that's being rendered, but there's also a class name prop. And so what that allows us to do by passing that there is it allows the users of our library to be able to override any styles that they need to mess with or include their own styles. And by doing it via a class name prop, that is technology agnostic. So while we're using Emotion for our styling, we're not forcing any teams to use that. They can use their existing styling setups. If they have style sheets in their app and they want to customize this, they can pass a class name, which is the class name as specified in their CSS file. Or if they're using, say, Emotion or style components or another library that's similar to those, this allows them to override. So the way Emotion works is it will take preference from styles generated and pass through this way. So this always allows us to have that open door for our teams to be able to work with our components without always having to follow exactly our styling. They can add a margin or change a color of something if they need to. With regards to the updating thing, we say multiple packages makes updating easier. So when you want to update a package, how many of us have been in a situation where a new we have something like Dependabot, or we just decide to upgrade a version ourselves, and we see the version bump. We go, okay, that's fine. It's just a patch change or a minor fix. We go and have a look, and something isn't right about it. Something breaks. The versioning's wrong. There's a problem, or there's a breaking change to the package itself. So it's a major version bump, but maybe that breaking change isn't on a part of a library that we even use. So by us splitting our packages into smaller packages, it allows the changes to be much more focused to what we actually have changed and what is relevant for that consumer. So here, for an example, we can see that our modals package has an update. We can see what it is. There's a bug fix. There's a bit of functionality that's been added. Now, the team that has this PR, they can choose, and based on this information, whether to upgrade or not, and whether they need to make any changes to their own app. Let's say for some reason this is a problem, this update, it doesn't hold them back from updating all of their other packages. So this is nice because, one, it makes the upgrade process smaller. It also removes any unnecessary code from being worried about by teams. If a team's not using our modals, for example, they don't need to be reading these change logs when we publish new versions, because it's not going to be bundled into the one large change set for the whole ecosystem as a whole. So that's really nice, but how can we manage that? So we use a monorepo. So I don't know if people have heard of Learner as a tool. It allows the orchestration of this. So it works alongside Yarn workspaces. And so you can see on the right side here, this is the entire config file that we have for our Waffle setup. And to be honest, even some of that could be removed and it would still function as we need it to. The most important thing, as you see on the second entry, version independent. And that's great because that's what allows us to have each package have its own independent version. And so when we publish changes, we use conventional commits to be able to determine the changes in each package. So what that will do is it will allow us to, say, publish a breaking change to a package, and all the dependencies can absorb that into a patch change, and all of our versioning is correct. So this is the tool that allows us to actually work in what at first glance might be a convoluted setup of having all these packages. So then the last point, and probably the most important point, is documentation is everything. So this is where we can step beyond the simple style guide that we had before. This is what is really what makes it a full design system, is that this holistic approach to it. And so as part of that, the documentation is for everyone. This might be a bit of a weird thing to get our heads around as engineers, but documentation in our case has multiple audiences. So there is the technical documentation for developers, and that's where our instinct goes to when we're documenting this code, because it is a library at the end of the day, and so it needs technical documentation to allow people to use it. But what else does it do? We also need usage documentation for designers and product managers. So they're the people that might be making the decisions about where these components get used and how they get used. And by having a documentation for them as well, and opening up beyond purely technical documentation, it helps to get everyone aligned on that. And also the one that I'm probably going to talk about the least here, because it will be the least interesting as for engineers, but actually is one of the larger sections of our documentation, is the brand guidelines for marketing. So this includes things like grammar and tone and voice documentation, guidelines on, for example, various product names within our ecosystem, which ones are capitalized, how things are spelt, how we refer to things. So this is a big section of our site. And while it doesn't necessarily seem directly relevant to software engineers, the fact that we can keep it adjacent to the technical documentation for the components themselves, it means that when someone is designing a section of a product, we are the one-stop shop for how to do that. Essentially, we contain all of the information about how to just construct your copy to go onto the page, how to lay the page out, how to and then for the engineer, how to actually implement all of that stuff that's been designed. So documentation is really key and actually is the largest part of what we do. But from an engineering point of view, the way that you can make yourself get excited about documentation is that it's an opportunity to so-called dog food our components. So if you're not aware of dog fooding as a concept, it comes from an old TV advert, I think, is the story I've been told, about selling dog food that was so good that even the owners ate it. So it allows us to use our own components. Our documentation site is just that. It's a website. It's a web application. And so we can build it using our own components. So here's the homepage of our documentation site. And we see here, it's an opportunity for us to try things out. It contains our links, our text, our iconography, our layout cards, navigation. It's a great opportunity for us within the team to be able to check that our components work within a real web application before having to distribute them to teams, because that can take a while. Also, as an example of how we can make documentation more interesting, we have some very dry documentation listing the props of components and what they do, what the default values are, what their types are, all of that sort of stuff, which is handy for people who need to go and check a specific thing. But sometimes it's useful to have this opportunity to be able to just play with components. So we include multiple examples on our pages. And so these are also live examples. We include like a live code editor on our documentation page that is already pre-populated with examples. So here you can see our button. There's a basic example for the button. On this page, we have other examples for the button. This is one that highlights how we can have different types of buttons. So a submit button versus a button you click versus a button that functions like a URL link. So that's all well and good, but as engineers, as much as we like making products for other people, we all tend to like making our own lives easier. So hence why there's so many local development tools. So how can we make this sort of architecture work locally? How can we have the same feedback loop as an application developer? Application developers have tools such as, say, the hot reload in Webpack that allow them to work with the code, decrease the feedback loop. Also, as an application developer, what you work on is the final destination of that code. It is when what you see is how it will be used, because that's as far as it goes. For us, building a library, we don't have that same feedback loop. So how can we try and bring that gap a bit closer so that we can work on code in a similar way to working on an application? We spoke about our documentation site before. That's an example of it, in that lives within the same repository as all of our packages, so that can run live. However, it's a bit convoluted and it's a very specific use case. So we use Storybook as a local development tool. So we have stories for every component and also common combinations of components as well. So you can see here, this is an example of one of our button stories. So we can see all the variants of buttons. We can see them with a loading state and with a disabled state, different sizes, different colors, everything that you might want to do with a button, essentially. And then on the left, you can see there's even more. There's buttons with icons and text. And then nestled into all of those drop-downs, there's a lot more stories that both contain components and combinations of components. And so what this does, Storybook just works like a local application. So I run this locally when I'm working on code. It has all the built-in hot reload that an application would, but it gives us that nice playground. And by saving all these stories, it allows us to always come back to a nice setup. So if I'm working on buttons, I don't have to figure out which combination of a button is an edge case, how many different types of buttons could there be, that sort of thing. That's all handled here. And if I need to go and fix a bug on, for example, buttons where there's an icon and a text, I can have all of them within view real time as I'm working on them, which is really handy. The other thing we can do to aid with local development, along with many other things, is test everything and then test it again. So, like we said before, the feedback loop is longer when developing a library. If I make a change to a component, I can't see the results of that change in real life until I've published a new version of the package that uses it. And then one of our teams makes the upgrade to use that new version, and then they deploy their website. So it's a long feedback loop to figure out if there could be any problems within it. Also, we have multiple dependents. So our library is used in multiple applications, and so that does make rolling back a lot harder. If we ship something with a potentially dangerous bug in it, then 6 teams all upgrade at the same time is very hard for us to roll back. So the point of these two is this is somewhat, testing is important everywhere, but I feel like when we're shipping a library, the level of importance is a little higher, in that because of these things, the feedback loop's so long and it will take a long time to be able to fix anything. There's so much more of an emphasis needed on getting it right to start with, and testing is a really good way of doing that. There's some upsides though. So the fact that we're developing components in isolation means we can try things like test-driven development, and we can build proper unit tests for front-end components. So at this conference last year, actually, I saw a talk by Tim Doherty, who's talking later today, about test-driven development on the front end. And it's a big deal because a lot of front-end engineers don't necessarily have the same, respect for testing as people who work on the back end. And so, whereas I'm a big believer that React or Vue or other component systems are a great opportunity to really flex those unit testing skills within a front-end context. So it's actually a lot easier for us to write tests than it would be if we were developing an application, say. We can, because we're shipping individual units, we can test individual units. That being said, it could also help to have some broad snapshot tests. So normally, unit testing is considered a great way of testing because when you do something and you break something, you see which unit test failed, and that tells you exactly what you've broken. That's true. However, as a second layer, this is where the and test it again comes in. We also conduct broad snapshot tests that just snapshot all the way down the tree. We use React testing library to run our tests, and so we can mount a full tree of a component, snapshot it, and store that into our repository. The value of doing that is unit testing is all well and good for isolated things, but let's say, for example, we change the font size within one of our text components. We also would like to know, at the point we make that change, what else has that impacted? Because we need to know whether to increment a version as a breaking change across which packages. And so by having some broad snapshot tests of everything, it allows us to do that, because by making a change, conventionally making a change in the text package shouldn't fail tests in the button package. And with our unit tests, it doesn't. However, with our snapshot tests, it does. And so that means that it's very easy to update a snapshot, but it gives us that warning flag that the button component, for example, in this case, needs to increment its version as well to go along with the changes that have been made. Also, consider using mutation testing to ensure test coverage. I don't want to go into this. This is a big topic, but we actually use a tool called Striker to run mutation testing on our code, which allows us to have some confidence that our test suite is somewhat complete. All right, so that's all about how we're going to build it. But what are we actually going to build? That's an important question, and that's kind of the most important question, really. So we're going to talk a bit about atomic design. So let's say start primitive. So what is atomic design? So this is atomic design. It's a book written by Brad Frost, it applies to design. It's not an engineering book at all, but it's very natural when working with a component-based system such as ours. So the way a designer may approach it if they follow this philosophy is that everything is constructed from progressively larger things. So they start with their atoms, which are the smallest units of design, and they combine them together to create molecules into organisms, into templates, into pages. So a template could be something like a nav bar. An organism could be something like each nav button. A molecule could be the text within it, and then the atoms may be colors or fonts. Obviously, there's a blurry line. You can't say, hey, a button, for example, is that a molecule or is it an organism? It doesn't matter. But the point is that you should build from left to right. You should design from left to right as well to ensure the consistency. If you start with trying to build a page or design a page without having your rules determined for each of the individual elements, that page is going to look very different to another page that someone else is building in parallel. Whereas if you start with your atoms and work your way up from there, that's how you will achieve consistent design. And so the nice thing about this is actually very natural and quite unsurprising for someone as a software engineer, because this is how we work as well with units and unit testing. So we work with atoms to use the design language, which would be your smallest functions or components or anything like that. And we compose them together to build larger and larger things. And at the end of the day, we have our, in this case, React application. So the important thing is this left to right process. And so that's what we should apply when we're starting building our design system. So we started on the far left. And so that is with tokens. So what are tokens? It's the most primitive information within the design system. So we wanted to get as small as we possibly could to be able to come up with some ideas and some rules about how things should look. So there's raw values for colors, sizes, spacing, all of the data that we need to design things. And what format are then? They're in JSON files. So this is even a step more agnostic than our old style guide, which was using SCSS variables. This is purely the data. There's no opinion on how it's going to be used. So this is just JSON files, for example, colors, which just maps names of colors to hex values, which later can then be used to build out things like components or anything. So the reason we do this is because although we are predominantly React-based and most of our applications are React, not everything is. We do have one application within DataCamp that's written within Vue. And so while they won't be able to use our components that we're building on the React side of things, they can still have some level of consistency by using these tokens files. We have a mobile application as well. They can also use the tokens. And also, even with outside of the JavaScript world, a lot of what we produce as DataCamp is our Python content for data scientists. And so if they're working on visualization or something like that, they're using tools like Shiny, which is a data visualization tool. And so by having technology agnostic files, they are able to use our design language within things that aren't necessarily our web applications. And we distribute these in their own package. So everything within our design system are NPM packages. So we can distribute these to everybody, and tokens live on their own in isolation so that they can be used on their own in isolation if they need to be. However, we expect most people probably won't directly import tokens, but we use them a lot internally within our packages, and then some of these other cases can use them. Let's talk about text. I think text is probably the most primitive set of components within our design system, probably. It makes sense that you can't get much more primitive than text. So it contains a selection of text components with the base styles applied. So we have a few components in here. As some examples, we have a component just called text, which renders a span with some basic styling. It sets the color and the font and the size, the default size. We don't really expect anyone to use this externally, but it's very useful for building other components. So, for example, when we build our buttons, we can compose this text into them. Some of the components that are useful and can be used directly, for example, paragraphs, headings, there's a whole load of them. All sorts of text. And those are more complete, those can be used on their own. So, as an example, this is some examples of our text components. So you can see here, there's a heading, paragraph, there's a links, strong, small, code, all sorts nested together to be able to create this text. This is handy. You can see as well, for example, if you look down near the bottom, there's that red text set using a class name. So that's an example of what we were talking about before. By adding the class name prop, you can override a style on something. So here they can use our text component, set a color on it, but they've got the correct font and the weight and the spacing is already set for them. So this is cool, but there's a bit of a problem with starting at this end. And so while conceptually this is where we want to be building from, our atomic design left to right process, it's very hard to integrate this or to persuade people to use these components. If someone's building a brand new application, great, they can just pull in our paragraph, our headings, all of that. If someone's got an application already, they've probably already got some styling, they've already got paragraphs, they've already got some style sheets. So why would they use these components? It's a tough sell. However, it's important to start at this point, but at the risk of spending too long there, this is where this next step comes in, is that less primitive components will be more useful, could be more useful. So we build a Markdown component. So this is almost coming at things from the other end of the spectrum. So here, this is an example of how we can just compose components together and the real power of this style of architecture. So this just orchestrates the pre-existing text components. And it immediately provides value. It can drop into an existing application. We have applications that don't have Markdown. They need to support Markdown because they're getting some content out of the database. They need to display it. How do they do that? They can import our Markdown package and go from there, and it works right away. And it just uses React Markdown, which is a library for parsing. So it uses that, and it sets some theming rules that just use our text components. So as an example, you have something like this. We have a Markdown component. It takes source. It's very simple, this, and it could be blindingly obvious to a lot of you. But this is kind of the power of this, is how simple it is. We build our text components. They are very useful for us, maybe not that useful for anyone else. We build our Markdown component. That is useful for other people. But the reason it's so simple and powerful for us to be able to build this Markdown component is because we've already determined how the text works. We've determined what is the gap between a paragraph and a heading, what font sizes things should be, how things should go together. And so we can build something like a Markdown component very simply and very easily because it's just a wrap around a third-party library which handles some of the logic and then our pre-existing text components. Another example of value from a more complicated component are dialogues. So if anyone's built a dialogue or a modal before or had to put one in an application, you know it can be a challenge. It's not necessarily the most difficult challenge, but it's not routine. And so if you've done that, you'll know that there's a lot of potential solutions to it. There's libraries that can do it. There's different ways of doing it. There's different user experiences with dialogues. And so what we aim to do is to standardize this UX. So how do you close a dialogue? Well, in our case, we have decided that there should be a close button. If you click the background, it should close it. And if you hit the escape key, it should close it. Great. That's a design decision that if we ever decide to change, we can change it within our dialogue component. We don't need to communicate that across the organization and across 5 or 6 different implementations. So how does it work? Again, we just use a package. We use a third-party library, React Modal, because we've decided that that's probably the best one for our needs. And we've added some of our styling. And so we have a dialog, a modal, that composes of other things. So here we can see that this actually composes a lot of our components, and to this date is probably the most complex component that we've built. So we can see there's the buttons, there's the text, there's some layout, there's the card that it's actually displaying in, there's a close button, there's a background, there's a whole lot of things that come together to make this work. But each of those on their own are incredibly simple. And so that's kind of the power of what we've got here. And I've got a nice visualization that hopefully you can see here that a colleague of mine made for me out of our repository a few months ago. So this is the state of our repository about 2 or 3 months ago. Each bubble, let's say, is a package, and we can see that in reality that is come together this atomic design principle. We can see on the far left we have our tokens, like we spoke about, but we can see there's a couple of other very low-level packages. We have a utils package that just contains some common functions that I extracted from some packages. We have an assets package that contains SVG files for logos and similar. And we can see as we work our way across, the second item in the second row is text, like we spoke about before. And if we follow that across, we can see it goes into the Markdown, as we spoke about, and into the button, and then all the way to the right, as we spoke about, is our modals package. And that contains dependencies from all sorts of things. So this is sort of the power of it. And it was quite reassuring to see this, that when we ran this analysis on our repositories, that it did match up with that atomic design graphic from before, because it's the same thing. This is just on a technical level rather than on a design level. The important thing about it is that everything flows in one direction. So things flow from left to right. Our most primitive components are on the left, and they get progressively more complex or compound as they go to the right. So you look at our button towards the bottom right-hand side. You can see that's got, 5 dependencies on all sorts of things. It's got the tokens, which will be what it uses for colors and things like that. It's got the card, which is the basic shape of it. It uses icons, it uses text, it uses a positioner to be able to show a tooltip. We can see that it composes all sorts of things together. And that's kind of the boundaries of our system, is as a design system, at the moment, modals is as far to the right as we're going to get. As we grow, this is going to become taller, I guess is the word to use, with the shape that it's got. It's probably not going to become wider, because as you get further to the right beyond modals, that's where the applications start having their specific behaviors for their applications. They can start putting in their business logic. So now let's talk about how do we make some decisions. So we know how we want to build things. What do we build? How do we do it? So let's talk about a case study of increasing some adoption. So let's talk about buttons. Every design system has a button. If your app doesn't need buttons, it's probably just a website, and this is massively overkill. Just use old school HTML. So with buttons, API design is essential. Implementation is pretty easy for buttons. They're very simple. The difficulty is conceptual on a button, and it's the API design. So what props does a button need? I mean, it feels like a simple exercise. There's going to be some functionality related ones, such as on-click, almost certainly. Maybe some others, on focus, on blur, who knows. Some functionality ones, maybe some data attributes if you want to track things. There's going to be some stuff to add there. And then there's going to be some style related ones. The size, probably a class name like we said before, to override things. But then color, how do we handle that? That seems obvious that you just put a color prop on. But here's an example of some buttons within our world. You can see it's not entirely obvious what color would do to that. So let's talk about how we can control our appearance. So we could leave it totally free. We set a color prop. The engineer passes a hash hex code for the color, and there we go. It sets it that 3AC, that's that blue color that's on the border. This is great. It's totally free. No one ever reports a bug that a color's missing. It just works. However, it relies on engineers looking at colors. This doesn't really help anybody because an engineer needs to go to our documentation site, look up what a color is, and pass it in. It's not useful. A designer might decide, hey, actually, in this case, I want to use a slightly funkier shade of a color, and we end up with inconsistencies. So how did we get around that? We use intent mapping. So whereas we could keep a color prop and pass in names of colors, for example, primary. So then if we decided to change the primary color, that happens. We still have the same problem in that there's not really any information. If we're thinking about it from that holistic perspective of we want the design system to say everything, including the contextual information, here we can say the intent is danger and it will set it to our red color. We have an intent success, those sorts of things. And this is great because this allows us to have that contextual information. And now we have designers and engineers talking the same language, which is what we always want to achieve. The intention behind the button is obvious. Whether it's obvious to the user or not, that's then a design question as to how they can achieve that, but is obvious within the engineering and the designer discussions. How can we get those blocky shaped ones before? Well, we added another dimension. So we said, if we set, say, appearance equals primary, we do something like this. So now we have, as opposed to a system that would be easy to implement in CSS, where you just have classes, one class per button variation. Here we have a 2D system. We have the intent of the button and kind of the strength of the button. So we have some rules within our design system that if you have a group of buttons, you have as many default buttons as you want, and then always only one primary button. So then that's immediately obvious how you can use that. And that is taken separately from what the intent of the button is and the color that the button will become. So whether that decision is right, again, that's a design decision. If we want to change that in the future or change our mind about that, we can do that. However, we're consistent and everyone's speaking the same language. The reason I bring up buttons for this section is because we implement something like this. And then this is a screenshot from another of our applications. You see here, these are completely different. Again, there's another type of button. And so this is the point I wanted to make, is that different teams, the whole reason we're building the design system is things are inconsistent. Now, do we try and come up with a rule as to why you would use these buttons, these sort of minimal, borderless looking buttons with the colored icons? As of now, we don't. We just ignored this. There's an application using them. We'll get to that in the future. It's that sort of agile principle is that we're trying to solve for some people and we can iterate upon the button. Button, believe it or not, is one of the hardest things to design. Because it is so simple, there's so much opportunity for people to use different things for different ways. So instead of spending years and years focusing on all the different types of buttons we could have, we came up with a system that works for 80% of our use cases. We've shipped that, we're iterating on that, and at some point we'll get to this. Maybe this is another appearance. But what we need to do as a design team is come up with the reasoning as to why someone would use this button instead of one of our other ones that already exists. And that brings me to the final point. And that point kind of covers everything up until this point, which is to think about what the actual value is. This is the dilemma that we have. Why would a good developer want to use this new package or component? We have great engineers. They know what they're doing. Everyone is fully capable of building any of these things. We're not really solving massive technical problems for people here by building this sort of stuff. So although we're approaching this as something that we're trying to do because of a design decision or a branding decision or a marketing decision, the people that are going to be using it are other engineers. And so how can we make it so that those developers or those engineers want to use our packages or our components? So the documentation is a good example of that. By making it very easy for people to use it, then it lowers that barrier. And a lot of what we do, a lot of the decisions we make are about lowering that barrier to make it very easy for the other engineers and the other teams to be able to use our stuff. And then the rest of it comes down to quality and trust. So by shipping great components that are high quality and building that trust with all of the engineers, they then begin to see that our components are great. And what we don't want to be in a situation of is having great engineers who think, oh, I can just build this now because it will do a better job. If they can trust us as a design system team, they can use our components. And so I just want to finish with a final little point about that is, hey, we can do little things that take decisions from that engineer. So we can do things like this. This is our alert dialog. It's a version of our dialog that is more simple. It just takes a title, a description, and the intent. And those intents map to the colors. A little thing like which button gets the default focus. So when it opens and you press enter, what happens? You see on the left, when the intent is danger, the cancel button gets the default focus. So there's no risk of someone flicking through and accidentally doing something destructive. If the intent is success, the default focus goes onto the confirm button. So when someone's trying to create something new, they can just hit enter, go straight through, all good. It's a tiny feature. It's a little thing that nobody implementing a feature from a product manager within an application is going to put the time into considering whether this is the way to do it, or making those decisions, or making the implementation. But by us having made those decisions and done that implementation, we have that little added value that the engineer doesn't have to think about this, the designer in that team doesn't have to think about this, and they can just focus on the user flow and the user experience. So that's it for everything that I've spoken about. I just wanted to quickly put this up here just so that people could see the tools that we use: Emotion for styling, Learner for the Monorepo, React testing library for testing, Striker is the mutation testing framework that I touched on, and then Storybook is that great local development tool. And so that's it for my talk. I'm going to swap back to the other screen so that I can see the talk. And I'll go through and see if there's any other questions from people. So Vincent says an alternative method to create customizable components is to use CSS variables. Like props, these can be passed down as the component. Yes, CSS variables are great. When we were starting out, we were looking at those. It was just a decision that we made to not use those and go with the CSS and JS approach. But as long as you're thinking about that value of being able to control something and ship something to the other teams within the organization, that to minimize the amount of work that they have to do to be able to use our components, then that's kind of the point of why we use the CSS and JS approach. But yeah, the CSS variables also can achieve something similar. So I think we're out of time. If anyone has any other questions, feel free to hit me up. Thank you for listening, and thanks for coming. Cheers.